So now that we have the variation, we should be able to make the player to move depending on where we are clicking. So what we're going to do is, just like we have the click origin, we should make some sort of movement origin for the player, or the player's original position. So I'm going to make here a private vector3, then original position. Okay, so we're going to save this. And whenever we click, whenever we start the player's movement, which is taking place here, I'm also going to add a original position equals 2. So I need to get the original position of the player, which is transform.position. Okay, this is going to be our anchor, where the movement starts. Okay, the original position. And now when we are here, which means we are moving, the player should change its position. Okay, so what we have to do here is we're going to type transform.position equals to a new vector3. So we're going to build the player's new position. We have to set the values on X, we have to set the value on Y, and on Z as well. But the catch here is we're not going to make any special movement in the Y axis. Okay, and why is that? If the player is jumping for some reason, we don't want to change its vertical position. We want gravity to be untouched. We just deal with X and Z. Okay, so on Y, I'm simply going to copy whatever position we have. So that's transform.position.y. As for X, we're going to start with the original position.x. But then, if we did it like this, the player wouldn't move at all. So we have to add an increment. Okay, and here is where things are going to look interesting. Here, we're going to get variation.x. Okay, so we're going to get the value that the player moved, and we do the same thing on Z. So original position.z plus variation dot, and instead of using z, because variation contains only two axes, x and y, we use y. Okay, remember, we are making a mix between a 3D game and a 2D game. Our player is only going to move in the x and in the z axis in this specific game. So if we use X, okay, the player is going to move horizontally, but if we use Y, so if we move the mouse up or down, or we touch up or down, we change the depth of the player. That's why we do this, Z here and Y here. Okay, let's save this and let's give this a try. I'm going to Unity. Let's wait for this compilation to be finished. Let's also stop this scene. And now I'm going to press play. Okay, so if I click here and move to the left, notice that the player is moving, which is fantastic. Okay, it's very simple. I just click and I move, and it's going to move the same way. Okay, and if you were on a bigger screen like that, okay, if you maximize the screen by clicking on this drop down menu and pressing maximize, it's going to behave in percentage. That's why we did that logic. Okay, doesn't matter if we are in a big screen or a small screen, screens with small resolutions, it's still going to work okay, in the same proportion. But as you might have noticed, it's a bit difficult to control our player. Okay, well, it's very hard to move. Okay, we have to click several times in order for the player to move to the other side, and this is where we're going to improve our player a little bit. We're going to add a public variable here that is going to define the player's speed. So now I'm going to type public float horizontal speed. Okay, and let's default that as 10f. Okay, we might change this, and we're going to use this horizontal speed here where we use the variations. So we're going to type variation.x multiplied by horizontal speed. Same thing for z, multiplied by horizontal speed. So I'm going to save this, I'm going to Unity, wait for the compilation to be finished, and if that's too much, we can at any time change that speed. Okay, so we press play, we have our player here, and now it's looking like this. Okay, the player can move closer to us, can move further away from us, and we can move much easier from the left to the right. Okay, and there are a few things we have to do. Okay, in a few games the player is going to be able to move in the depth axis, but in some the player won't be able to, and it's the case of this game. Okay, so let's not use the z-axis. And how do we change this? Okay, we can make another variable here that is going to be a public bool. Then we're going to actually, instead of bool, let's type vector3, And then we're going to type here something like axis available, something like that, or just bool lock z. Okay, that works just fine. We can start with as false by default. Okay, it's going to lock the movement in the depth axis. And here, where we set the position in z, we should actually ask a question, because if lock z is true, then we want to repeat the position in where it was. So we're going to type lock z, and we add a question mark. Okay, if lock z is true, then we're going to type transform.position.z. Okay, let me do this. Okay, if lock z is true, transform.position.z. Then we add a colon, because if lock z is false, that means we are going to move in the z-axis. So that's a ternary operator. Okay, we're simply asking question. If that is true, we return this first value. If that is false, we return this second value. We can save this, go to Unity, and give this a try. Okay, so with the player here, we can press the play button. Okay, and if we move the mouse up and down, it's going to move closer or further away from the camera. If we press lock Z, up and down no longer moves the player. Okay, as you can see, it's completely locked, only the horizontal movement. I think we might want to change that horizontal speed a little bit, so to 15. Yes, 15 is going to be interesting. So let's stop this and set it to 15. Okay, so the movement is working very well here. Okay, we can quickly move the player to other positions, but the movement right now is instant. Okay, the player is moving straight to the position that we defined. So how do we smooth that movement to give a more professional, a nicer look to the player? To work on this, we can make another variable here that is going to be private vector3 target position. Okay, so this is going to be our the position where the player is going to be. Okay, and we do this because instead of straight setting the position here like we're doing, transform.position equals to new vector3, we're going to type target position equals to new vector3. Okay, so that's good, that's going to work, but how do we make the player to move? Here in the bottom of the update method, okay, before the clicking or touching logic, we're going to add a new comment, which is going to be movement logic. And now we're simply going to type transform.position equals to vector3.lerp. Okay, this method is going to make a linear interpolation between two vectors, and that means it's going to basically smoothly change a vector3 from one to the other at a certain speed, at a certain rate. The first parameter is the original position, which is transform.position. The second one is the target vector, so we simply type target position. And the third value is going to be the time component, so how quickly that interpolation is going to happen. I'm simply going to type time.delta time, okay, for you to check this out. Okay, so now let's save that, let's go to Unity and see how that smoothness is going to work. Okay, so I'm going to press play. The player false. If I move here, notice that it takes some time for it to reach the target position. Okay, so that's some sort of movement smoothness. Okay, it really depends on how quickly you move from one place to the other. So that's something that we want to change. Okay, so a few things first. That name horizontal speed should be changed to something like movement amplitude. Okay, this is going to be the factor that we're going to use to multiply the movement based on the variation of the click that we did. So we're going to copy that amplitude and paste it here. Okay, and now we can make a global speed variable, public float speed, and let's use maybe 8 as the full here. Type 8f, and here where we do the movement logic, we're going to type transform.position, target position, time.delta time, and now we type multiplied by speed. Okay, multiplied by speed. So you can save that, go to Unity, and give this a try. Okay, apparently horizontal speed is still used, so you can just double click. There we go. This is going to be movement amplitude as well. Okay, so in case you face any errors, just double click and it's going to take you straight to the line that is giving you a problem. Okay, now we press play, and if we move to this position, it's going to be here. If we move it like this, it's going to be here. Okay, so we have some smoothness going on here for us. Okay, so it's going to work just fine. Okay, and you might have noticed that when the player fell, there was some stuttering, okay, until it reached its target position before, well, it stabilized. So you can actually fix this, okay, you can actually adjust this. If you see the signature of vector3.lerp, okay, it's going to return another vector, okay. So what we can do here is type vector3 smooth position, okay, or smooth position is going to be that lerp that we did. Okay, so it's going to look like this. And now the transform position is going to be a new vector3 that is going to be smooth position.x, then transform.position.y, and finally smooth position.z. So it's more or less the same logic that we did before. We're not going to mess with the vertical position, just x and z. Okay, once we finish this, we can give this another try. So we press the play button, then the player is going to fall to the x and z position, and it's going to move. Okay, if we lock z, we only move in the horizontal axis. Okay, so let's stop this, mark lock z. We're going to save our scene, and then we have the full player movement.